Hello, hello. Right. Back at the cinema. I'm gonna play you a horror movie today. And no, not I shouldn't say that. We're gonna dive into one of the most dangerous and complex programming paradigms accessible to human mankind. Web Flux and reactive programming. My name is Victor Rentea. I'm a Java champion, coding for almost 2 decades, and over the last 10 years, I've been doing workshops in consultancy in very different companies throughout Europe. My main area of interest is clean code architecture unit testing, but I also do frameworks, of course, Spring, Hibernate, Reactive, and Webflux. Performance and secure coding. If you want to check out my website, you can find out more. So you have to understand, folks, what I do day to day, every day of the week. For example, from now until 20 December, I do workshops with different companies, with developers from different companies every day. And basically, every week I am in 2 or 3 companies, remote, online. And I get to see a lot of pain and a lot of issues. And why I started saying that reactive programming is the most dangerous paradigm? Because during 2 workshops at some customers of mine, I found bugs in production during the workshop. I was telling them about some pitfalls. I'm going to tell you about it to you also. And they, at some point, panicked. They looked to production, and they had the issue in production without noticing it. I'm going to tell you more. I have a community which became the largest developer communities in the world on software crafting. That roughly means clean code architecture and unit testing. So we meet every month after hours. And we get together on Zoom online and then live streamed on YouTube to talk about different things. For example, in November, I scheduled a presentation about microservice saga, maintaining consistency. You can join us completely free. It's 1 hour in English after work, 5 p.m. local time. All right, 2 kids, 1 cat, and a garden. Boom! Ha 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 ha! You should print this. Put it at the top of. I want to start with a question first. Who of you is working currently with reactive programming, Webflux or Reactor? All right. Now, who of you knows this picture? Oi, oi, oi. I would have expected the same people. Ay, ay, ay. Like 1/4 of you. This is arguably the most important picture in reactive programming. Let me throw you right in. So, without other introduction, we're going to say, here. In this game, we're going to talk about a subscriber. A subscriber is like you having a subscription to your mobile phone, like wanting data. This guy wants data. The subscriber wants data. The publisher has the data. Okay? The subscriber will will subscribe to the publisher, right? And the publisher gives back the subscriber a subscription. This subscription over here will be used by the subscriber later to pull data. To tell the publisher, give me more, give me more, give me 5, give me 3, give me 7, give me everything you have, unbounded, right? And when the publisher would receive that order, basically, the publisher is going to emit that amount of elements as requested. So imagine now already asking Cassandra, which is one of the most powerful databases in terms of scalability in the world, telling Cassandra, give me everything. Can you imagine a cluster of 20 machines pushing you data at the same time? Do you see your production going down? They're going to shut you down, basically. So if you can't keep up with the rate of which the publisher pushes you data, you have the control to tell it to slow down, which is called back pressure, by requesting less elements at a time, like requesting 100, 100, 100. So there is this game of, I want data, you have the data, okay, give me at a rate that I can control the subscriber. Good. Now, every time you ask for data, the publisher will push you data, but as well, it can push you an error, saying, you know what, I don't have the data, or something went wrong, or simply, I'm done. So there will be three types of signals going from the publisher, who has the data, to the subscriber. Here is your element, here's completion, and here's an error. Okay? We're going to come back to this picture several times. Now, reactive programming is programming with asynchronous data streams. So whenever you have streams of elements arriving to your application at a rate you can't control, that's a goal for reactive programming. That's the scope of reactive programming. Okay? So the publisher is the one owning the data, who pushes the data. The subscriber is the guy listening to the data, okay? And the subscription is the means through which the subscriber can retrieve data from the publisher. Okay, okay. And I told you also already about the request, about flow control, how the subscriber is able to pull more or less information from the publisher. We won't talk much about back pressure today, at least with one little exception. But back pressure is something very important for reactive system built over a reactor and Webflux. Good. Now, besides the publisher and the subscriber, we have the concept of an operator. The operator is, we will put like dot map or dot filter or dot flat map. That is an operator. You know it from streams, from Java 8 streams. This operator, what's very important to realize is that it's both a subscriber to the upstream publisher, and it's also publishing data downstream to whoever follows that operator. It's very important that you should analyze every operator in this term. Every operator in a reactive chain is both pulling data from above and pushing data downwards to its own subscribers. Okay? So it's both at the same time, publisher and subscriber. So for example, to put a snapshot of some real code we're going to see, if you have a flat map operator there, that's going to subscribe to the buffer operator above, right? Basically asking data from above, okay? Receiving elements from above, and then it's going to push down data to the map that follows it. Okay, that's a very important thing to use in our discussion later. Project Reactor. Project Reactor is for backend, where Eric's Java is for Android. Does this make any sense for you? No. There are different reactive frameworks, 2, 3, if you include Vertex. So we have what? Project Reactor for backend, supported of course by Spring, right? We have Eric's Java, which due to some politics misunderstanding got broken apart, and now we have Eric's Java on the Android, and we have Reactor on the backend. All right. Yeah, too much text. Now, at every stage, everywhere where we're going to look today, you're going to see two concepts everywhere, Flux and Mono. I'm talking now to those of you that never had contact with reactive programming. The others of you that are playing with this, you have tattooed on your back, Mono and Flux. Yeah, you have that with a heart, right? Flux forever, right? Nice. And I'm going to tell you something that will make little sense right now at the beginning. If you are only using monos in your code, you got into the wrong room. You should go to the next room. But let me explain. In the next room, because this won't appear on video, is Venka telling you about virtual threads and other ways to do non-blocking work. If you are only manipulating mono, right now it doesn't make any sense yet, then you don't need reactive programming. If you only manipulate mono. It's maybe too much to say, but you'll get the point eventually. At every stage, we will be talking about the Flux and the Mono. Now, when you have this stream of asynchronous events, that's a Flux in Reactor. Okay, Flux is a reactor concept. Now, this thing over here will emit you elements. These bubbles over there are elements, data elements. For example, bringing orders. The first order, the second order, and so on. This black line over here is the completion. The way to tell the subscriber that you're done. You don't have any other row in your table, for example. Okay? Now, you can construct a Flux manually like that, but that's not really important. We're not going to play with silly code. We're going to migrate a real application written in blocking style to Webflux and see how things evolve. A Flux can also emit a single element. For example, you expected many, but there is only one result matching your query, for example. Right? A Flux can give you nothing. Give me all the orders, none found. Okay, empty. A Flux can also be infinite. What the heck is an infinite stream? It's like you're listening to a Kafka topic or a rabbit queue. That will never end, right? Or you're listening to events coming from the browser that the user, I don't know what he did in there, hovered the mouse over some button to check out. You know that Amazon, if it sees you hovering your mouse over the add to cart button, that's an event on Kafka. If you just hover the mouse, and they know it. Victor is hesitating. What can we do? What can we do to propose him that product? How can we convince him, right? These are events that you can listen to with your application. That will never end, right? Error. You might have a Flux ending in error. Hey, query failed. The query is incorrect. Or, I don't know, there is no more, or something crashed. Error, of course. Now, Reactor has a specialized kind of publisher, which is called a mono. Now, a mono can only emit 0 or 1 elements. Okay? It can never emit more than 1. So we can have an element, you can have no element, or an error. Okay? Again, something critical for Reactor is that you cannot pass a null as a signal. It's null. Reactor has allergy to null. You can never emit a null as a value. Hey, there's a null. Never. It can never work. Right? So we will instead of emitting a null, you're gonna have an empty mono. So you can't possibly put null in here. As a consequence, you're gonna not put any element. You're gonna say completed. But that will give you an empty mono. And you will see today operators that have weird behavior when you pass it an empty mono. You're gonna see. And also another practice, personally, before playing with completable feature and reactive programming, I never heard about the void class. It's a class. It's a big V. Okay? A mono void really means you're not going to give anything back. So a mono void can never emit any value. So it's a good practice that if a function does something for you and doesn't return you any result, it's good to make the function, to declare the function to return mono void. To shout out, it's clean code, right? To shout out, I'm not giving you anything. Mono void. All right. Oh, and marble diagrams. Marble diagrams, you're going to have, again, pictures all over the office with marble diagrams. Trying to, this is a simplified marble diagram. Let's understand what goes on in here. First of all, up on here, you can see a flux. You see a line with the time flowing to the right, and you see the completion signal and elements, all right? It's very critical to understand marble diagrams. It's the only way to survive in reactive programming. Then, down below, you have another flux. But here are squares, not circles. Isn't that cute, eh?
Isn't that cute?
What does that mean? It means the element type changed, all right? Now, how did they change? For every element in the original Flux, I played a lambda finding stuff in a database. It's quite common to enrich data like this. And then for every circle coming in, now this baby over here, from here to here, is the operator we're looking at. For every element coming in, there is a new, what is this? Let me highlight this. This baby over here. This baby over here is a mono, because it emits a single element. You see just the square here? No other element? So that's a mono. Mono. Make sense? A mono emits a single element and a completion. So what does this really want to say, the diagram? It means that when the circle comes in, suppose that's an ID, for that ID, you're going to fetch something from the database. So this is what happens. And then you're going to wait for the database to reply with the square, and you're going to push the square further to your output flux. So you have an input flux at the top. On top of you have an output flux below you. Time flows to the right, right? And for every element coming in, you're going to subscribe to some mono to fire a network request and bring some data. When that comes in, you're going to output that data falling through you to your subscribers downstream. All good? No. If you want to leave right now, I'm not offended. So, okay, good. Well, let's see what goes on. 3 rules we have to keep in mind for the entry point. There will be a huge summary of 15 rules at the end, but these 3 you have to have already in the back there. Nothing happens until you subscribe. If you have a mono or a flux, to call some network, to do something out there, nothing will ever fire until you subscribe. If you don't subscribe, period, nothing runs. Now, however, despite the fact that you'll be tempted to call subscribe on a mono and a flux, you don't do that. We are not allowed to do that. I'm going to explain more details as we progress. So don't subscribe or block. Instead, you need to return that publisher out until you give it to Spring. Right? You pull at least if you are in a REST controller method. And with that, I think we can go to code. OK. I wanted to sit down this time, although I don't really like sitting down, because it's not easy what I'm going to do. So let me introduce you to the idea over here. The Git location and the slides are already posted on social media. Twitter, to be precise. We have Web and Flux, two projects, two Maven modules in the same big Spring Boot 3 Java 21 project over there. Is it 21? Yes. Which one of them is implementing in a blocking style, and you can inspect. You know what's very fun for you later. And I designed this in such a way that I have a test running to target both the web, the classic one, and the Flux application. So I would invite you to play with this with your team, with your fellow colleagues back home. Try to reproduce exactly what I'm doing right now. So I'm now pushed on this branch, and I have a test that I want to make green every step of it. Now, what you probably want to study later is the contents of the POMs to see how, for example, a data Mongo starter changed into a data Mongo reactive starter. Okay, you can see what changed from one place to another. But without further losing time, let's jump in. All right. Mind also that I have a Docker Compose in behind running some services in here, like a Postgres, a Mongo, a Rabbit, and a WireMock. Just like the ingredients, right? A bit of salt, a bit of flour. Right. I'm going to connect to all of these today. Now, I have some flows that are already written in an imperative style. My goal today, if it's not too bold, is to migrate these flows one by one into reactive style. Okay? And let's start with use case 1, get all authors. Without losing any time, I'm going to copy this from here. I'm going to paste it into a similar folder into the reactive world. Right. And I'm going to see what breaks, basically. It breaks that I don't have an author repo. What the heck is the author repo? Let's go there. That's a Mongo repository along with a document. Very fun. Let's take them over here. You know, what's the scariest thing I ever saw during a workshop? Someone in front of us did right-click, copy. Using their mouse. We are blocked. What is he doing? He wants to what? It's a kind of it's a new religion that we copy with click control, with right click to suffer more. I'm going to copy author repo and author repo, here these two, to the Mongo folder. Now, the document remains unchanged. Although, I have a single problem here. I have two tables, two collections in Mongo. In order to make sure that the two applications don't collide with each other, I'm going to point this document to another, let's say, author 2. I'm going to change the collection, not to point to the same one, okay? And author repo, I'm now in the reactive world. What's the rule here? Every time you hit network, right, you need to do that in a reactive style. So I'm going to move to a reactive Mongo repository. All right. Let's see what breaks now in my code. All right. Just. Now, a question. Find all in a reactive repository, what would it return me? Flux, because there are many, exactly. So, no more list for you. So that's a Flux. Let me show you that. Come on. I'm trying to put a key. There, come on. What was that? There, thank you. Flux of author. Thank you. And then the flux of author has to be mapped. What would we do here? And I will go ahead and ask you, what would I return at the end in a controller endpoint that is supposed to give me a collection of something? It's not a flux again. I'm going to return a flux because I'm going to push my elements as they arrive from Mongo. I'm going to push them as fast as I can over the network to my client. Good. So that's a rule already. Every time in a method, somewhere, you hit network, you need to return flux for mono, period. Now, every time you do network, you need to return flux for mono. Find all, map. Now, in the map, in a reactive chain, this baby over here is not supposed to return, to block in any way. In the map method, you have this new, and if you do map, actually, we can continue and look at fetch email. Look at fetch email. Fetch email retrieves the email of a given author from remote. That's a network call. I already know that this will be here a mono of a string. But let's not see that yet. Let's see just that the REST template is no longer available in a web Flux application. So I'm going to inject myself a web client. OK? So instead of REST template, I'm going to say web client, get, and then .uri. OK? Retrieve body to mono. Done. What this gives me back is a mono of a string. Is a sort of a completable future, if you want, right? Or a promise, if you want. And this over here, I need to return out. like this. I knew it was coming, mono of a string. Good. Now, what do I do with the mono of a string here? I should have warned you that we're going to see extreme functional programming today. We're going to see lambdas, in chains of. Over here, this little block I've selected, it returns a mono of a string. I need to pass a string to the getAuthorResponse object. So what would I do here? Well, the first thing that comes to my mind is block. But if I say block, that's going to block one of the reactor threads, and that's not allowed. You are blocking in a place that you should not be blocking. As a matter of fact, Reactor is kind enough, I think. Let me just, it says, I don't have, wait, I have another problem. The find all over here did not return, the Flux over here, did not return any element. Why did it return no element? Well, at the beginning of the application, at the startup, in a post construct, I do author repo save to insert some data. But IntelliJ is kind enough to highlight that this save is never used as a publisher. What the heck does that mean? And only then you realize that the save in the reactive repository returns you a mono. What's the rule? Nothing happens until you subscribe. I did save. I never subscribed to this mono. This is a mono, right? Look, a mono. I never subscribed to this. As a consequence, in my database, in the table author2, there is no table author2. Nothing got inserted at my application startup. So here, I need to do something for this to fire up. Now, generally, I told you on the slide that it's not recommended to do block, but there are some exceptions. One of such exceptions is when you start up your application. It's perfectly reasonable to block and delay the startup of the application until Mongo succeeds in inserting the document in the database. Right now, the application restarts in the background. When you refresh, you're going to see author2. Right? So just because I did .block over here, this is one place legal at startup. I'm going to put, can I put here all the moments when you're legal? In a blocking MQ listener and in a scheduled. In such cases, you are allowed to do block. Other places avoid it. But here, let's continue. The block over here, what would it do? Right now, the Flux from the find all emits me a value, emits me an element, right? That author I've inserted over here. And the first test passes. But that over here is not a good practice. What can happen? In a dark world, you could imagine the fetch email having a glitch, having a, I don't know, downtime, being depressed, having a slow response time. If it responds you very slow, every such call for fetch email.block is going to block one of the threads in Reactor. And Reactor has a finite number of threads, ending up with maybe even paralyzing your application. It's called thread pool starvation issue, is what virtual threads are getting us rid of in Java 21. Here, however, I'm not allowed to block. The rule is, every publisher you have, you need to give it to someone, to return it and to chain it until you return the whole chain to Spring. To see better the picture, let me extract this as a method, 2DTO. Getting the author document as an argument, and then converting to a getAuthorResponse. But this baby over here, this is a mono. Whenever you have a mono of something or an optional of something, what we usually do is start with that and do map. Whenever that email is going to come to me, then do this. And instead of that, email. It's just like I would hook a callback to an asynchronous network call. This is how it feels. And I'm going to return this. So starting from the fetch email, when the email comes back, I'm going to create the author's response, enriching basically the author with the email retrieved from remote. And of course, this method returns now a mono. Of course it does, because it hits the network. I knew that already. Alt-Enter, make it return a mono. Nowadays, what we have here, if we inspect the types, we will see something very beautiful. I'm not sure if you ever gave someone a present in which there was another present. Optional of optional. Streams of streams. Right? Flux of flux. It's just like Christmas.
It's beginning to look a lot like Christmas.
And when it's Christmas, you want to unwrap the extra packages, and that's the F word, flat map. All right? You flat map and you get rid of one of the extra wrappings in there. Done, and that should work. I just forgot to return and save. I have DevTools, which restarts the application every time I save the file. I'll build the project, basically. So right now, it's the same thing. It's still green, but it's more reactive in the sense that I'm not blocking any thread. Okay? So this is use case 1. Use case 1. All right. Let's see use case 2. This was warm-up, folks. Okay? Let's see use case 2. Get all posts. Let's see. It's a post repository. Who are you? Post repository. Hibernate. At this point, many people panic. Hibernate. Because Hibernate doesn't support reactive programming. The way it's designed, it's not tolerating reactive programming. So I'm going to give up Hibernate. What do you say? Look, I'm going to paste here in SQL, and I'm going to use a very lightweight ORM, which is built inside the Spring that no one knew about. R2DBC repository. R2DBC comes from a reactive database connector, just like GDBC, which was blocking. This was non-blocking. Okay? So you can talk to an SQL database in a non-blocking way. Quick parenthesis. I'm not really sure that your reactive system wants to talk to an SQL system. The kind of applications we build with reactive systems, with reactive architectures, are very fast and taking a lot of load. A poor Postgres over there, flooded with 1,000 parallel connections, not sure is the best choice. But to migrate the project as promised, I'm going to go there, and I'm going to change from post entity with GPA. I'm going to change it to use the thing from Spring, which is table and ID. Who knew? Who knew that Spring data has an annotation ID? Okay, doesn't do any lazy loading, any auto flash, no. It's just reading and writing from the database, nothing fancy. Here, find all in a reactive SQL it's going to give me, again, you told me, a Flux. Okay, that's a Flux of posts. For every single post, I want to get post response new and then to list. And then at the end, when I want to return out, that will be of course, Flux. Okay, Flux. So Flux in, Flux out. Just converting in memory. It's okay to use map here because it's an in-memory transformation, not doing any network call. Cool. And that should make another test pass. Woohoo! Just the two ones, the first two ones were that easy. The rest will be a bit more complicated. Let's see. Use case, and I will probably commit use case 2. I'm still alive. Good. Use case 3. Get post details. This one brings in comment repo. Comment repo is the other Hibernate entity I used to have. Folks, just for the sake of completeness, you can still use Hibernate in reactive systems, in Webflux, but you need to wrap it in a bounded elastic scheduler to be able to make sure you don't block critical threads inside of the reactor. All right? So here, comment repo will do the same change, R2DBC. And if I find by post ID, I'm not going to give a list, but a Flux. All right? Good. Now, the comment itself, again, like I did previously, I'm going to switch from using GPA to this simple Spring thingy. Good. Done. Am I really done? Done? Save? OK, good. And the post details here. Let's see what happens inside the flow. So we have a post repo and a comment repo. Both are reactive SQL repositories. I'm going to collapse this. It doesn't help. And this. Find by ID. What do you think find by ID gives me back from a reactive repository? Mono is a single response. Right, of course. Right? Notice that we are losing something. You're going to see later. Yeah? We are losing the exception. So this, however, is a mono. Post mono. All right, and now we will start weaving together these monos, you'll see. Comment repo find by post ID, by the post ID, gives me again, because it's by ID, a mono, it's a Flux, it's find by post. Give me all the comments for the parent posts. Good. Transforming each of these into a Flux of comment response. Good. Now, at the end of the flow here, in the actual response, I have to have a list of these comments. Right now, I have in here a Flux of the comment response. You see, there's a problem. I have a list, comments coming in one by one at the rate that my Postgres pushes them to me. And here we have a comment response list of comments, all of them. So I'm not fun with Flux here. I need to do a collect list to come into a mono of a list. And here's your first marble diagram for today. Not the last, but the first. Come on, here. What does this mean? From the flux above, elements coming in, when the flux above completes the black line, then the collect list emits as a single unit, as a single data element, all the elements collected until then in a mono, and then finishes the mono because it's a single element. You see? So above is a flux, below is a mono. Okay? Fun. So then what do I do? Well, the first thing that comes to my mind, that's a comment mono. The first thing that comes to my mind is, of course, because I'm an imperative developer, block. Not okay. So what do we do? Anyone knows what I'm going to do next? Is it obvious? Let's see. You have two asynchronous promises, two asynchronous things that are coming in the future. What do you do with them? Zip. Mono zip. I'm going to take the post mono. I'm going to take the comments mono. And I'm going to pass a beautiful post comment function here, which is going to build me the response I need. The result of all this mono zip is going to be a mono of this baby, right? I'm going to transform. This is hard for anyone new to asynchronous programming with completable features or reactive programming. The idea that the two things in the future are going to be joined together, and then I'm going to have access to what those returned as arguments. So this lambda, I'm able to do more stuff with the data coming in. And that, as I told you, it's a response mono, which, let me just be geek here. Oh, yeah. And then the response mono I'm going to return to Spring as promised. Every time you can return something to Spring, a publisher, a mono, Flux, Spring, do it. Spring, when you return the mono, is going to do three things. Subscribe to it in a non-blocking fashion, waiting for the result to send to the client. Give you something very magic. It's called reactor context that contains the metadata of your requests. Imagine security context, you're going to see. Or trace ID in Apache Sleuth or OpenTelemetry, right? And also it's going to handle cancellation. If the client browser closes the connection, it's going to cancel your flow, calling cancel up above. Right? So that's why you want to return every time to Spring. And then post mono. You'll see in the next example that is a good practice not to define variables of type mono and Flux. And I'm going to do the same. I'm going to inline all the variables in a beautiful zip of post repo find by ID and find by post ID, map comments, collect list, and merging, joining the two calculations with this. Okay, maybe this is too much for this hour. It's during siesta. Maybe this is better. Huh? Omelette de fromage. Excellent. So save, run the test. So it's not easy, but it's green. That's important. Use case 2, but yeah, use case 3. I'm here in use case 3. We're good. We are green. Use case 4 failed, the create post, but use case 3 appeared to work. Okay, very good to go. Commit anything here else? No. Done. Use case 3, proudly done. Fun. Now that we're warmed up, let's head for the real. Use case 4. Create post. This is the first complex one. Let's see. Use case 4. Please copy from here. Right-click, paste. I'm kidding. I'm kidding. Use case. OK, good. And what happens in here? Let's see. We are creating a post, of course, by a post repository and a comment repository, Reactive SQL repository is good. I'm going to do a post mapping, pre-authorized. Opa. I have a restriction that only authenticated users can create posts. Okay. And then I do post save of a request of an entity, of a new post. I'm saving it into a Reactive repository. When you save it into a Reactive repository, you're going to be given a post of that. Remember, nothing happens until you subscribe to this baby. If no one subscribes to this post mono, nothing happens. Good. Now, the problem is that on the next line, I need here the post that was created previously to fetch its ID and link a comment to that newly created post. Make sense? So the first thing that I could do is post monoblock, but that will, I told you, don't do that, so I will avoid. And instead, I will remember, let me just, that I can have access to what's inside this mono of post with either map or flat map. Now, looking in advance a bit, I realize that I'm in this whole game here, I'm going to save over the network to someone else. As a consequence, definitely, this baby is going to give me a mono, or a flux, probably a mono. Now, this mono over here, I need to chain with my own. Therefore, to put it in another way, in a map or a filter, you are not allowed to do network. If you want to do network, you don't need to use map, but flat map. To chain the new call into your chain and to subscribe to that guy, flat map. So now I have access to the post inside. I can do this baby inside. Okay? That kind of makes sense for now. Let's just keep fixing compilation for now. I need the post also to send a message on Rabbit. So here, this send post created event, I'm going to do the same. I'm going to do the same because I'm new to the reactive thing. And does it work? Let's see. It's a post, send post created event. The problem is that this returns me void. What can I do? I'm trying to send a message over the Rabbit. One way to handle this is to do on next. Do on next is a callback that gets run. Every element is emitted from above. What does that mean? It means that when the post mono here is emitted, this will execute, effectively sending the message over Rabbit. Good. And me coming from imperative world, I think I'm done. Let's not mind the yellow warnings from IntelliJ. I'm going to run the tests. This is not going to insert anything. Why? Why? I mean, like this, neither this, nothing. The post will not be there. The comment will not be there. You can check out the tests if you want, but that's what they are saying right now. Nothing is inserted, nothing is sent. Actually, these two never work. Because I never subscribed to these publishers. I mean, like, these two are never, this is what IntelliJ is telling me. Hey, you subscribed to it. But I know how to link them together. I can do a zip. The problem is now that you know already that I can say flat map, I can say return, and return a reactive chain. For example, I could do return this. But that means I will give to Spring a mono, basically this mono. The flat map and this chain will now fire up, and the save will happen. But what do I do with this baby? I need to chain it too, right? So what I can do here is to do the do on next in the same chain somewhere after I insert, or maybe before I insert the comments. So what am I doing? I send the post created event, and then I save the comment into the database, okay? Creating the initial comment. Again, you can see a nice reactive chain, 1, 2, 3, chained one to the other, and that's a pattern in reactive programming. Chain, 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 return to Spring. Run. Let's see what happens now. We have use case, one more run. Okay. Use case 4 says, null pointer exception, cannot at this line. Create template, no, not here. Cannot invoke authentication get name. Perfect. Where is that? In this line here, I'm using security context holder. Now, in a blocking world, including when using virtual threads, when you start executing on a given thread, you never leave the thread. This is a traditional way of working with handling HTTP requests in Java on the backend side. As a consequence, historically, we've been adding information and metadata about the current request on the thread local. Anyone heard of thread local until today? Thread local. No, that's like 2/3 of you. Good. That magic place where you put stuff and that gets carried away with you wherever you go. Now, in Reactor, we keep jumping from one thread to another. So they could not have possibly bind anything to the current thread. As a replacement, they've introduced something called Reactor context. Long story short, to implement this in a reactive way, you need to do a security context, a reactive security context holder get context. Now, many people don't understand why this get context returns you a mono of security context. What's the magic behind? The idea behind is that this mono of context, okay, this is going to be a tricky one. For this to give you the actual security context, you need to subscribe to it. And every time you subscribe to some mono or a Flux, you carry along with the subscription the Reactor context. So if I want to enrich a bit the diagram we've seen here, when you subscribe above, where are you? In here, maybe? Nah, I want a simpler one. Just a second. Here. When the flat map subscribes to the buffer, because it's right? Basically, the flat map subscribes above. Along with the subscription, it propagates this magic thing called Reactor context. It's a map. It's a hash map. It's a map moving upwards to how you following your subscribe chain, right? And then up here at the top somewhere, maybe several layers above, someone will want to see the current user name. But that thing was added by Spring at the bottom of this chain and propagated from operator to operator until this guy in that invisible Reactor context. So the Reactor context is a map that is carried from the subscriber into the publisher in a web function, a REST controller method. Spring is subscribing to your monos and adding the security context to it. Okay? That's really, really tough. So that's why this is a context mono, because to get access to that and basically get from the context, get outside the authentication name like we did over here, someone needs to subscribe to this baby, okay? So long story short, this is like the mono of the username, like the username mono. Good. And again, someone needs to subscribe to it. But the point is, the comment that I want to construct using the username, to be able to instantiate, I need to unpack this mono. How do I unpack this mono? Username mono, map. Map because it's an in-memory transformation. I don't do network to instantiate a comment, right? And I'm going to say, given a logged-in username, then instantiate the comment like this. What this gives me back, I return. So you see, this method suddenly has to return a mono of comment. Whoever is going to subscribe to this is going to propagate from operator to operator until this guy, who is going to give you access to the security metadata. Like I described previously, I'm not going to use any variables. I'm going to inline variables into a single lovely chain. Isn't that cute? Don't you want to stop doing whatever you're doing and do this instead? Okay. And then do map again. Let's do, because I've seen, psychologically speaking, in the teams playing with reactive programming, I see people much more geek, much more, hey, if I can use 4 dots, let's use 4 dots, right? Yeah. It's a mindset. It's a mindset. It's a mindset. It's not wrong. It's just a mindset. Good. Create initial, and suddenly this baby over here now returns me a mono of this new comment I want to save. Starting from that comment, I'll save it. So I need to swap these two around. I need to start with this baby and then save it like this. Flat map because I'm hitting the repository. So flat map, comment repo, 4 dots, save. Or if you want the long version, entity, save for that. So once I have a comment, flat map, save it, okay? And that should propagate the React. So again, while the tests are running, what happens right now? Let me bring it in the same picture. I return back to Spring here, this flat map. Spring subscribes to flat map subscribes on top here, subscribes here, causes this to touch the database, and then that emits a value down. That value, that post, is given to this Lambda fun. After that runs, is given to flat map, which then subscribes to the create initial comment in here, which subscribes to this guy who is able to unpackage the security context. Emitting value, value, value. That value comes here and it goes to this flat map. Who's going to subscribe? Are you still alive? I'm not sure how much can I... OK, you get the point. Does it work? Let's see. Not yet. What does it say? Ooh, 500. Method not allowed. What am I doing? Let's try to restart. Sometimes it has a delay. OK. OK. People actually destroy this method and put this all this, because why not? We can put this into here somewhere. But let's make small methods 3 or 4 operators 4. It's still red. Why? What does it say? Method not allowed. What do you mean method not allowed? Post mapping. I'm missing a what? 50? Oi, have a compilation. The semicolon. Don't you love Java? You tell me. The semicolon. Yes, we are fighting monsters, and the semicolon killed us. And that's the bytecode did not. Epic fail. OK, use case 4 is running. Oh my God, ladies and gents, fun. But yeah, let's see. Are we all green? Yes, all green. Amazing job. Right, fun. Cool. The only problem here, right now the code is OK-ish. But it has a little issue. The fact that this send post created event is sending over Rabbit, and that is hitting network, or at least doing some sort of I/O. If it's storing locally or hitting HTTP, it's sending that message somewhere. And although it's not visible right now, it could turn out to harm us later. I actually had a client that had the problem with sending messages on Kafka, and because on high load, Kafka wants to offload on disk, the writing on the RocksDB on my disk bottlenecked the whole flow. And the writing in the database became the bottleneck of the entire flow. One single database, they had to write synchronously each message, because there were too many messages to send to the broker. It cached some of them locally, and the cache bottlenecked. Can you imagine how stupid this sounds? The cache bottlenecked. Anyway, so this one, if you want to play it in a different way, you can. Let's see if I remember how to do that. It's called outbound message. And you can inject yourself over here a sender, which is the reactor driver for Rabbit. Okay? I want to do that, please. It's a radioactive Rabbit. Huh? There you go. And radioactive Rabbit, this, has the way to send with publish confirms just the outbound message, all right, to a what? To a send options, I don't care. To a send options? I think it's like this, something along these lines. And the post created event, let me refresh my memory. How is it called? I think I should fetch it from here. Post created event. Thank you. This is the reactive driver to send Rabbit, right? Of course, like anything reactive, is gonna give me back something with mono, right? And giving me back a flux even, because I might be sending multiple messages. I need just to wait for the completion of that flux. I don't care about any message, just tell me when it's done. And I'm going to say then, and return here back a mono void. So you see, out of a radioactive Rabbit sending a message, I don't expect anything out. So I'm going to reply with the mono void. But now the method where it's called is not subscribed. You see? It's not subscribed. How can I fix this? Well, I can do flat map. But if I do flat map, I change the element. Because flat map, given the post, returns me void. Right? I lose the element. So what I can do here is to do map and come back and return the original post. It's actually then return. Then return, please. Then return. Thank you. Right? And basically, take the post from the closure of this lambda and return that further. Right? You do realize that I am in a lambda and then in another lambda. But actually not a lambda, but after a completion. I can do that, or I can discover a reactor operator from among the 100 plus, which is called delay until, which is doing exactly this. This is just an example of the many operators that can simplify a bit your life if you know them. If you don't, they're going to give you more headaches. What delay until does, again, marble diagram, is going to wait for the original, just a second, it's going to wait for the original element up above. When that element comes in, it's going to fire, in my case, a mono void, discarding any values from that mono void, and when completion comes from that, it's going to emit the original circle down. What's not visible here is the blue arrow to subscribe to this mono. That blue arrow fires up everything. That blue arrow sends the rabbit message in the end. All right? Let's see if I got it right. See whether the test works. It wasn't really bad what I was doing before with the rabbit template, but this is more reactive and more non-blocking, if you want. All right? All good until here? Not quite, huh? Yeah? Wow. Yes. Any thoughts, questions, please? What would happen if rabbit fails? Would the whole flow blow up? Yes, thank you. Do we need to test that? Yes, thank you. But first, let me call my manager. Yo, Biz, what if rabbit is down? Should we not be able to create posts? We don't care about the rabbit. Oh, poor rabbit. You're right. They don't care about the rabbit. What should we then do? In case the rabbit fails, on error, resume, I think it's called. It's on error, return or resume. Whatever error, exactly, whatever error, swallow it and return an empty. Okay? And done. Fixed. Right? You can just silence the error. Okay. Other things, other thoughts here? If not, yes, please. Yes, on line 46. On line 46 over here, we have, let me put it on the, now it's better, right? I explained it. No, I'm kidding. Look, what happens here, thank you for the question. What happens here is that given a post from above, the one created, with the ID inside and everything, I need to get the ID of the post and the request title from the inbound request object, and pass it to the create initial comment. Why does this have to be returning a mono? Is because inside of it, it uses reactor context holder to retrieve the current username. Therefore, I have to subscribe to it with the blue arrow. Every time when I draw the blue arrow will be a subscription. I'm going to subscribe to that, passing the reactor context from Spring. And remember when I drew that thing on the screen? That was the explanation. So I subscribed here to this baby, and then this subscribes to that, this subscribes, and then subscribes to this, giving you a security context back. Once that comment is created here, that mono comment gets out, I need to save it. And now, why is it a flat map? Because given a comment in that mono, I will take the entity, actually, the bad, no, I know why I don't have it. Here, much better. The comment from inside that mono is sent to the repository, and then I have to subscribe to the save for anything to happen. So I have to flat map it. Any other question? Any other thought here, please?
But if you care about the rabbit,
yes.
it fails, and then you want, let's say, go another path, but don't want to save the comment. Let's say you save for later event processing.
But the comment is bound to the post. I really think you need to save the comment anyway. But you are saying if the rabbit fails, to do what? To take another path? To do something else? Exactly. Well, in that case, instead of returning here an empty mono, do your stuff. On the error comes from above. When the error comes from above, the error signal comes from above, from the send post created event on Rabbit. That error signal is going to get translated over here into anything you like. I put it a mono empty, but you can then there on this subscribe arrow do whatever. do more network, save stuff in the database, do whatever you want, right? So to recover, you're basically saying, what if I want to park the message in a table for later processing? Then you can do that and save into a repository. It's a bit of cumbersome work, but this is the way in this function. Please. Right, and that would allow me to not do lambda in lambda. So the observation is that I could close the parentheses here and do this. Isn't that cute? That's better because I don't do lambda in lambda. I will transform, and it's actually much better like this. I mean, like, much readable. If it is okay or not to do the save of the comment after you send rabbit, I don't know. If send rabbit might time out, I don't know. But we're playing it, right? It's baby steps. Now we have a mono comment and then save. Other thoughts on this example? I like better taking questions, ideas from you guys. Interesting. Very, very interesting. Let's recap. And exactly this is the feeling. The teams stare at several lines of, I've paired program with them. There was an awkward silence, everyone looking in there at the code. For 10 minutes, one of them printing the paper with a pen, drawing like I draw it. What the signal, trying to understand who to subscribe. Let's do it one more time because it's so fun. Let's do it one more time. Let's fit the screen better, like this, and let's try. When you return this mono to Spring, Spring subscribes to this guy, this subscribes to this guy, this subscribes higher above, and then finally it subscribes to save, which brings me element. Let's put them in green, the elements. The element goes here. When the delay until has an element, can I show you the Java doc for it? Let's see. Yes. When the delay element has an element, it will fire up one more. It will subscribe to this. It will call the lambda and subscribe to the new. The blue line is not visible, but it's here. You need to read between the lines, between the JPEG. It's there. It's a blue line, which causes this line to fire up. Reading the marble is one of the most complicated. So this delay until is subscribing to what exactly? To this baby. The on arrow resume, because it's an operator, subscribes to this, and this fires up in here, comes back with, actually not here, but down below to the rabbit, which fires a message on the queue and returns you back, what? A mono void, nothing basically, just a completion signal returns you. That completion signal is ignored by the delay until, but if returned you instead an error, red. The on arrow resume is going to subscribe to this baby and is going to fire you back a completion signal. The completion signal is ignored anyway by the delay until, who is just going to play the post that initially got in. The green line, the green bubble here is going to be outputted at the final flux. All right. And then after that, the element, actually this empty over here, not the empty, the post from above, the one here, is going to get to this flat map here, which would subscribe to the initial comment. Now I'm going to throw myself in there. Good. I come back from there. I flat map, meaning that I'm going to subscribe to the save, fire the database, and then finally, eventually, finish and return the comment out. By the way, why am I returning the comment? Oops. Then, which gives a well-deserved mono void. Why would I want to return the comment? Doesn't make any sense. So again, staring at the screen. Good. I mean, real life with reactive programming, right? This is life. Hashtag. Good. What else here? Nothing here. We're done. If, of course, the tests pass. Use case 4, I deserve a raise. All right. Now, really now, the guys in the reactive teams that are handling 1,000 requests per second, stuff like that, they are 15 years plus, 10 years plus, like battle-hardened developers. Really hard to manage all this madness. Right. Let's do the next one. Create comment. Let's give it a try. How hard can it be? Let's see. First of all, let's fix the compilation. Instead of a REST template, by the way, REST template, you may have heard of the deprecation notice. Not deprecation, but maintenance mode. Are you worried? Did you know about this? Who knew about the maintenance mode? All right. Are you scared of it? Yes. What is going to happen with REST templates? Folks, they didn't change it for 10 years anyway. But anyway, they are pushing you towards the web client. Okay. But themselves, the Pivotal team, when they published this, when they put the deprecation notice, the community started crying, and they said, if you have a Spring MVC application that works fine, there is no need to change. Imperative programming is the easiest way to write, understand, and maintain the code, right? So if you have a large team, juniors included, may pay attention about the steep learning curve, like we discussed just now. A practical way to start is just to use webclient.block. And that's what I see in many teams. They do webclient.block, and they live happily ever after. There's no problem in doing that, especially with virtual threads coming into Java 21. So we expect that for a wide range of applications, the full shift to web client and to web Flux is unnecessary, because we are not handling that much load to take us down if we don't use reactive programming. Right? So in other words, it's perfectly fine to start with web client, and when you translate from REST template to web client dot post URI, right? All right, URI, and then it's perfectly fine to say here retrieve body to mono, and then at the end block. Nothing is wrong. If that block over here blocks a virtual thread, what, you wasted what, 200 bytes? So it's not really an issue in virtual threads. But it was an issue for the past 28 years since Java was invented, because that wasted over here in imperative programming, that wasted 0.5 megabyte of memory of a thread that was blocked, of an operating system thread that was blocked over there waiting for the freaking network that had the hiccup. Right? So here, body. Good. And then at the end here, body to mono. Retrieve first, of course. Retrieve. This is a request, yes. Just a second. Who put this require not null in my code? I didn't. So this, and this is a body value, I think. Thank you. And then retrieve, and then body to mono to this string class. And that's, again, a mono of, okay, good. Now let's call a friend to see whether he can do what I have to do next. And knowing that if this touches network, I'm not going to do block in front of it, because I'm trying to go towards to embrace reactive programming completely. With block, you keep out the dragons, you keep out the bugs and the danger, right? But if you really want to orchestrate these flows, and you will see in the next hour, a very motivating example with something that with only reactive can do. Right? So I'm not going to do block. I want to fully embrace the reactive paradigm over here, which means that if I touched network over here and there, these two things are going to return a mono of a Boolean, because I brought stuff over the network. Right? Now, what do I have to do here to return? I have to do result map OK equals. Exactly. What do I have to do here? I have to do result. Actually, that's a mono, what I want to do here first. It's a result mono, fair enough. And then, come on, Copilot, thank you, that's it. So I'm returning out a mono of a Boolean, which reflects whether the result from that guy is, all right, good, is unlocked. In this game over here, things are gonna get wild, very wild. Because this safe over here is now a mono. The same here. Okay. Let's call it safe mono. Safe. If we survive writing this example, we deserve a break, but it will take 10 minutes or something. Find by ID returns me a mono. It's a mono post. Good. What next? Folks, this particular example is too complex to migrate progressively. I need to big bang it a bit. Okay? I'm going to leave the original code up here, and we're going to write again, thinking step by step what to do. And actually, I'm going to write the code on top here, and delete stuff as we go. Find by ID is good to go. We need the find by ID to get the post from the database. Then, let me shut up the friend. Good. And now I want these two to happen. But you see, the two results, the two booleans I get from them, they have to be AND. What to do here? How to start? I will take the post mono and do what? A flat map. A flat map because based on the post, I want to call to hit network. Is safe, I see it returns me a mono. So I want to change this boolean into my flow, like this. Good. This returns me a mono of a boolean. Okay. And that is my safe mono. Let's make a variable, safe mono. Up until here, all good? I want to take it baby steps. Right. Next one. I know that no one subscribes to this particular publisher. We are going to do that, but just a bit later. Let's repeat the same thing, post mono, to do the other call, to the is unlocked. Because you see, both need the post that was retrieved here. Post mono dot flat map the same, given a post, then play is unlocked of that post author. Good. And that thing is a, let's say, unlocked mono. Good. What do I need to do next? Combine them somehow. How? Zip it. Zip it. So mono zip. And we're going to zip the safe mono with the unlocked mono by passing a function over here that taking two boolean returns A and B. What? Yes, of course. Okay. This thing over here returns me a mono, what is that? Let's say safe to send, safe to save. Folks, I'm writing the code with an imperative style, but this is how I think, at least me. Step by step, I build my data, okay? I construct the data, but what do I do next? Let's see. I have inside the mono a boolean telling me whether I am allowed or not to save a comment. What next? I could filter. Let's try that. Mono save to save filter. Filter by the boolean. Strange, eh? If you want to be geek, and people usually are geek, you're going to use the identity function. Oh. But that's going to... By the way, does it work? No. Why not? Don't tell me it should be a Boolean identity. Let's stick with the basics. B, arrow, B. Nothing is... perfect. Filter. And then what next? So what would I see after I apply the filter operator? The filter operator, if there is an element not matching the filter, is going to skip the element, returning back a mono which is empty, basically. You see? So let me put a comment here. This filter is empty or not? The following. Mono is empty or not? What next? Flat map. Let's try that. So we say filter. I want to get the information from the filter here. Dot flat map. Good. I get now as the result the B. Perfect. And then what? I don't have the post, but I want to save it. Let's try to save it. This is how we think, right? The baby step. Let's iterate on this. Okay, like that. Comment. Very good. The problem is I don't have the post. Where do I get the post from? Oops. Any idea here? I lost the post. The B is the one from, let's call it B mono to be more. Zip it again. Yes, of course. Let's do it again. I can do it once more. Let's do this. That's exactly what you could be. Very good. Mono zip. When I want something from another mono, I can just zip it in, right? So so let's do this. Post mono, B mono. All right. And then what? And then a function taking two arguments. The first one will be proudly post. The second one will be B. Okay. Arrow. And now let's try to put this thing over here, right? That's what we are trying to do. All good? This is survival in reactive. I mean, this is what all of us did when they started doing reactive the first time. I was able to do the save. Congratulations. What next? It's me. What next? I actually did this also. I didn't do the throw. Whoa, what the heck is that? When should I throw this? Switch is empty. The filter removed the B if it was false. So the filter returned back an empty mono if the B inside was not true. If this was not true, this one returned empty. Empty if B equals false or not empty. Exactly carrying the true value in. So I can do here switch if empty. Switch if empty. Switch if empty and say if it's empty, then I want to play what here? Mono error. Mono dot error. And paste this in. Oh my God. What next? Log. Log? What log? Log? What do you mean? You mean like dot log? Block. At the end? Block, of course. Block. Ha! At the end, because I can't do this anymore. Block. Block everyone. No. You are this close to finishing it. Go. Return, of course. Every time you have something that you need to subscribe to, don't block, don't subscribe, return. Done. What? Let's see. Refresh. Reload the tests. This is use case number 5. Use case number 5. Not acceptable. Wait a second. Let me just try. What is this? I know.
It's beginning to look a lot like Christmas.
What the heck is that? It's a comment in a promise of a promise. So I'm gonna promise you, I'm gonna give you a beer. It's a promise of a beer. Excellent. Come on, what to do? You can't return a mono of a mono. It's nonsense. What should we do? It was so easy to code it before, right? I mean, like, think the original class. I'm going to do something very wild here. Flat map, M, arrow, M. What the heck is that? Your gut feeling should tell you we're doing something wrong here at this point. We should tell you, what is this? Doesn't look well at all. Your instincts should go like, alert, alert. Something is gonna... Let's see. Use case 5 passed many of them. Whoa, we are good developers. This garbage actually works. Amazing. Right, use case 5, I have a problem here. When I have a non-existing post ID, the code should have thrown an error. The code does not throw an error right now. Can you guess why? If the post ID was not in the database, this code does not throw an error. What line should I be looking at? 30 or 39? 39 is something that has to do with B. Much later than retrieving the post from the database. So what would find by ID give me if there is nothing in the database for that ID? Mono empty. How does mono empty look? Mono empty. What happens next if there is an empty signal coming from this to the next ones? Flat map. If the flat map receives an empty, just this line, no green thing. If there is no green thing, there is no let me draw this better a bit. I'm gonna put it to the right here. I want to draw on it. So if there is not this, then there won't be any this. There won't be any this. So what's gonna happen? The flat map is gonna return an empty. Make sense? Flat map needs a data signal to work. Flat map needs a data signal to work. If there is no data signal coming to flat map, nothing happens. All right. So, all right, fun. So how to fix it? Switch if empty. Switch if empty, like this, and say if from above there is an empty mono coming in, I want to play another mono, and that mono would be an error. All right, saying new, no such element exception, for example. That would basically, when this returns a completion, this would return an error. And all right, again. If a signal, again, single, the class single. Let's see. Single. All right. The signal operator expects one value, otherwise throw an error. Is this what I want? Yes, done. Single. If it's empty, it's gonna error. So you see, this thing over here is shorter than this. And of course, more geek.
Gangnam Style.
It's one word, and then again we stare at it. Single. Perfect, thank you. That was a nice one. Good. Does this pass all the tests for use case 5? Let's see this in action. And then I'm going to show you the bug I discovered in production in my systems during the workshop 2 times. They turned yellow, white. You know? They went to production. They came back. It was very fun. Twice. Fun, not fun. For me, it was a bit depressed because those guys had 12 years of experience, 5 of which in Reactor, and they had this bug in production. The bug is right now in front of us. Let me show it to you. Folks, looking here, first of all, do any of you suspect where I'm going? I'm curious if you see the bug in this code or not. Use case 5. Use case 5 works, but has a little performance issue, undetected. With what? How come I call it once? What do you mean? I subscribed to it not twice, 3 times. What? Very good. You found it. The post. Did you ever actually had it sometimes? Did you have the issue? Not production, but you discovered it yourself. Good. You see this post mono here is being subscribed 4 times? What? Let's do the arrow thing again. Yeah, again. So, let me okay. Spring comes to the party, subscribes to the flat map. Flat map subscribes to zip. Zip subscribes. Let's see the zip diagram. Although unspoken here in the diagram, let me put it on the right side so that I can draw it. What some people complain about these marbles is that they don't show the blue arrows. But the elder's wisdom says that if you see the black arrows starting at the same time at the beginning, it means there are some subscribe signals going to both of them. What does that mean? It means they run in parallel at the same time, and they are both subscribed at once. Zip will wait for both to emit a value. Fun. When both values are in, I'm going to merge them and return them further. But what happens in here is that the zip will subscribe again on both post mono and B mono. So I'm going to subscribe once here, and once to B mono. B mono will subscribe after some fancy things to this, and this will subscribe again to safe mono and to safe mono and unlocked mono. But when this subscribes to these flat maps, the flat maps subscribe to this again, once, twice, 3 times. Do you want to see this? Let's look in WebFlux log. The flow that we're trying to check is called create comment. OK. I'm going to search in my Flux for this. Something is fishy. I don't. Oh, right. I need to look for among the last ones. Here. Who would have thought? Who would have thought? I'm firing networks 3 times. You got it. You nailed it. How to fix it, you know? You can put cache in here. Single cache. That's the fastest way out of it. What the heck is... Folks, you know, there are only 2 things hard in programming. Cache invalidation and naming things. Ever heard of that before? When you put cache, you should be scared. I mean, all of us should be scared, because cache in general can produce inconsistencies, unreproducible bugs. Anyone had a problem in production due to a cache that they could not reproduce in local? There you go. You can hunt days for that, weeks. I know a team, 2 weeks they spent, and then someone said, hey, reverse proxy. You know? So in this case, the cache over here, however, is not a global per application cache. It's a cache in the reactive chain. That cache makes the followers, the other feature subscribers don't. So you see, let me put it in the right side here. This cache thing, when you subscribe first time, it subscribes above to the post repo find, returns the value down, right? But the same value here is stored somewhere inside the cache. So then when another subscriber comes in, that value is being returned to any future subscribers without the cache hitting again above. You see? So it's a cache per reactor chain. It's not a cache per application. Very important. And that indeed fixes the problem. Yes? Yes. Well, if 3 posts come in at the same time, the 3 posts will enter this function 3 times, the red, the green, and the blue. Each of them are going to do post repo, post repo, post repo. All of the 3 are going to create their own monos. Each of these monos is going to be cached inside. There is no communication between concurrent requests. That's what I was trying to say. It's not an application-wide cache. Yes, but the post mono, let's play the game again. Yeah. And to be honest, my mistake is that I'm not putting the operators 1 per line. Let's see again. String comes in, goes to this zip. The zip subscribes to the post mono, meaning the cache. By the B mono, zip subscribes once and twice, 2 more times. 3 subscribers to the cache operator. But the cache operator in there, any subsequent subscriber it gets is gonna not subscribe once above more than once. So yes, indeed, I'm gonna write here. There are 3 downstream operators subscribing to the post mono variable. But the cache operator does not subscribe above to single more than once. There will be 3 subscriptions coming to this guy, but the cache above would only fire once. Now, is your question related to multi-threading and parallelism race conditions in this regard? Or I've just answered this? Because you could go that way. You could say, hey, if the 3 subscriptions come in the same time, would the cache allow the second call to go or not? There is a dark moment there. If you think a bit, the 3 subscriptions may come in the same millisecond on different threads. What happens? You have to experiment to find out and read inside. But as far as I'm concerned over here, the cache saved the day because it only subscribes once above. Let's check that. In the log, here, find up. Done. Any other questions here? Debates? What? No, no. I'm going to refactor this completely after. Actually, from those teams having these issues, years later, they came back and said, hey, Vitor, we had a rule afterwards. You never define a variable of type mono or flux ever in your life. Never. Ever, 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 ever. Yes, please. Because then you can wire it twice. And it's very easy to get this wrong, super easy to get this wrong. And no one would write tests for that. You can imagine what happened if the first line 30 would be a save. Do you see 2 rows in the database? Now that gets really fun, right? Repeating a get call, inserting two rows, yeehaw, right? Yes, please. Yes, we will chain everything. Yes, the same idea. Instead of a cache, can we chain the whole thing? We will. We will do that after the break. But it's time for a little break, 10 minutes or 15 minutes. Any other questions related to this code right now besides this chaining thing or anything from before? If there are any questions, you can also approach in the... But it's time to have a little break. Let's put it 15 minutes. That means 12 past 3. See you back and enjoy the break. Okay, good. Another word better? Much better. Good. With more menace, right? Okay, so we have some improvement ideas. 2 or 3 folks came forward here and suggested exactly what I had in mind. I love it when this happens because it's a natural follow-up. The first question to address it in sequence came from there saying, hey, is it cache a good idea? What if people don't know about this cache? And they end up linking more times the same mono. Isn't this dangerous? Yes, it is. And I told you the conclusion that the teams had. They do not define variables of type mono and flux again. So let's see what happens. I'm going to undo the cache. I'm gonna get back to the bug, right? To the repeated network call. And now let's see what's going to happen if I will inline destroy the variable. I'm going to put post repo find by ID here, here, and here. And I guess anyone here in the room would now have a suspicion something is fishy, right? I mean, I don't think any of you is going to write code like this. Submit a pull request and say, I'm done. I don't think so. I mean, I really have a feeling this won't get pushed and submitted like that, okay? So, but then how do we avoid linking it multiple times? The idea is the same. You start with this post mono once, and you unpack it, flatmap, and then you say, given the post arrow and a lambda. Now, whatever comes afterwards, I'm going to push inside this new lambda that now has access to the mono, to the post inside. Just let me double check. So we have 1 hour in. Okay, done. If you do that, the post becomes available in the closure of this large lambda. By the way, I'm not a big fan of having such a big lambda. If I have a lambda more than 3, even my IntelliJ cries, hey, what is here, my friend? What is here? We are having a party. How many lines? Right? Yeehaw! Stop for Christ's sake. And then this flatmap. This doesn't make any sense. I have the post available already, right? Now, the post here is also readily available in the closure following from here. So I don't need to zip Kung Fu thingy. I just need to say, instead of this, baby, I need just to say, let's see if I can engineer it out with least invasive. Can I say bmono.flatmap, maybe? And then based on B arrow, this. Okay. And this flatmap M arrow M is gone. Is it gone? Please tell me it's gone. Gone forever. Return. Phew. It was weird, right? Flatmap M arrow M. What is wrong with you? Good. Post arrow. Does this work? You see the twist? I am putting the thing I need in a closure, in a lambda, and then I pour all the code needing that thing inside the lambda. And just the beginning, it won't remain like that, I promise. But for now, the tests, do they pass? Yes. Great. What next? Well, I have to engineer it out, and I will keep destroying the variables. I can inline the variable from here to there, of course. Done. Flatmap. And let's respect these operators. Remember the team looking at the single and then thinking? That line, right? That line can cause you headaches, can cause you bugs, can cause you... So open line by line. I once had a team, again, very, very experienced team. They told me that for such a function, they worked 3 months. Per programming, of course. Because you can't be alone, when including tests, performance, throttling, rate limiting, all sort of kung fu, more complicated than this, for sure, but this size, maybe a bit more. 3 months. Right? And they had, in total, with incidents, with bugs, with fixes, and they would keep looking. I mean, they could, it's like they knew it by heart. They could say it in the middle of the night. They knew exactly line by line. They memorized it completely. All right. Post arrow. Safe mono is used there. Unlocked mono is used there. I'm going to destroy the variables. Good. And I'm going to say is safe, is unlocked. And instead of that, I have a logical, I think, and, thank you, from the Boolean. Who knew? Who knew we have a method to do and between two Booleans? Isn't that geek? I mean, like, who would write this? But the point is we get more 4 dots, and that's very good. No, this one's better. Thank you. 4 dots. It's a thing. It's something in the air. Good. Mono save to save. I will destroy it. Okay. Let's see where this is going. B mono equals. When things will get too wild, I'm going to extract a method to explain what happens. So maybe this. Maybe this. Maybe this. Let's give it a shot. Can I? Because if I put it all together now, I think that's a bit too much. It is functional programming style, but it might be too much. Is unlocked, switch if empty, and then flatmap over here comes from here. Okay. So tell you what, I'm going to extract from here to. Although in practice, I've seen teams leaving the flows like this to have the big. It is one piece of code that it takes you 20 minutes to understand, but it is really. But it is one single. We don't jump to many functions. But I'm very close to extracting this. Very close. It's not that complicated yet. All right. Any other improvement way you see here? Actually, there is. I'm in a long lambda. I need the post at the end. Because I need the post at the end, I can't break it and come back with this on the baseline. I can't because I need to have in the closure of this whole thing the post from here. Okay, let's give it a shot. And this is, let's say, clean between quotes. Reactive, not clean, survival, reactive programming coding style. All right? Kill the variables, of course. Kill the variables. Kill the ifs, kill the fors, kill the exceptions. What are we left with? Lambdas. Really. So if we rarely do, exceptions we don't throw, variables we don't. Let's make a list. Do you want? My wish list. I wish I had in reactive. I wish I had. If I don't. 4. Are you not? 4. What for? Take a flat map. Okay. Variables. My dear, remember high school? Remember high school? Int, I, j. We were so proud of declaring more variables. No more variables for you. You weren't. Exceptions. What exceptions? We don't have exceptions anymore. You want to throw an exception? Take your hands off it. Do mono error. I didn't ever get to catches, but you can imagine, like, on error something. There are no more throws, no more throw, no more catch, nothing. By exception. So what are we left with in the end? Functions. Functions and lambdas. So is it safe to, I think it's safe to say that reactive programming, it's actually extreme functional reactive programming. So if you ever want to enter this world, make sure the whole team are gurus in functional programming. I mean, like, absolute. They master their Java 8 streams like, no problem, right? Because you can see how this code looks. I'm looking at that for any ideas in the room? How can I get rid of this filter here? It's really annoying, isn't it? Yes. But I'm filtering the result from is safe and is unlocked. I need to filter this. I can't move, if I understand correctly, you say to move this earlier?
Not exactly that time, but then move the whole monozip in that filter. So you would filter after single, then do that monozip inside that filter.
I can't filter after single because I don't have B. B got produced by this beautiful code. Beautiful. Right. I can't put the single above because there is no B up in there. Right? Please. You chain filters. Ah, that's what you mean. So you mean, am I basically filtering once here and again here? Interesting. So then I would return the post out only if, only if, but how would I do that? Let's try. Let's give it a try, a fair try. Oh my God. Rakia. So monozip, I'm kidding. Monozip over here, it tells me a Boolean. Yeah, but if I filter, I mean, like, this switch and this single were doing the same thing. Probably. I believe, God help us all, that if I say here delay until, and then if I switch if empty, oh God. But where is the post? I lost the post. Is it post here? Yes. We might have come with oh my God, the next parenthesis, and God help us all, let's run the test. Fingers crossed. I think they're long this way, but I think I can do better. I can, instead of delay until, I can say filter. Oh, yes. There we go. So you see us, how many of us are here, like 120, 200 people, looking at the code in profound silence and finding ways to, there is a filter when, by the way. Yes, filter when, who can play a publisher to return the Boolean out. These guys, you have to admit, they were artists. This is a publisher, a mono, bringing you true or false. This is a false, and this is a true. Beautiful. So a filter when, you could do it, filter when, and if both of them have to be true, I can do one and then the second, right? I can check, okay, so breathe in on your nose, breathe out on your mouth. If you do a filter, let's rewrite this because my head starts, I'm not sure yours, but in filter, if you do A and B, isn't this the same thing as doing A and then B? Please say yes. Yes, thank you. Right. It's the same thing. So then if I zip and AND, it's the same thing as doing filter when is safe the post. You see how far we go from where the imperative led us initially? Boolean. I don't need this anymore. Yeehaw. Yeehaw. Good. Oh my God. Ah, omelette angels are singing. Green. Fills your heart with joy. Make peace, not war. No more nested. It took us how many of us, right? You are actively participating, 6 or 7 of you, giving ideas to finally reach nirvana. Excellent. Switch if empty. Wait a second. Single! Ha! Ha 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 ha! This gets better and better. It's gonna take longer. I don't care. No, really. You could argue it's gonna take longer. But if you play this card, I'm gonna tell you that this code, if you are raising this problem, deserves load testing. So then I'm gonna fire Gatling, K6, JMeter, something. I'm gonna put wire mocks with some delays behind, and we're gonna optimize for performance. We're not gonna guess. I'm gonna ask, what is the SLA of this and that? What is the time? What is the, and then we're gonna ask more painful questions. Timeout. Oh my God. Retry. Oh my God. And so on and so on. And then the next thing you know, resilience for J. Anyone heard of resilience for J today? Resilience for J. Few of you, too few of you. What are you doing? Monolith? So here, is safe, single flat map. Anything? If anyone has anything to say, speak now. Or if not, keep silent. How's the word? Okay. Good. I'm pretty proud of this code. I can put it to my resume. This is how I can write code in reactive programming. I don't know how to write it simpler than that. Oh, I do know. I will take this. Oh, yes. Let me show you. Map. Oh, my God. Map. Yes. Don't tell me. And then the next thing you know, you're gonna, oh, yeah. Yeah. Much better. Beautiful, right? Amazing job. Good. Okay, good. Now, I have some urgent change request for the flow I just finished. Paul came to me in the break and said, hey, Victor, usually I return the ID of the post. It's fair. I mean, how would I know what I created, right? If I wouldn't know, if I wouldn't need the ID, why am I doing a post? Why not a message queue? If I don't, okay, this was big. If I don't need any answer of you, why do I use REST in the first place? Okay, this idea only takes for half an hour of debates in my workshops. But if I don't need an answer, what are you doing on a fragile, non-robust communication protocol? Why aren't you in a queue? But that's another story. I tell you, you love my workshops, it's completely wild. But the point is here. Delay until, I need the ID back. Okay, it's easy. So map, the ID. The post arrow, post get ID. But wait. What is this? What is this? Ew. Where is my post? Lost in transition. Somewhere in the digital transformation, it's called. In the digital transformation, it got lost somewhere. Where? Here, when I did flat map. Actually, even earlier. Look, comment. It's still, post. So what do? It's an honest change request, and this is real life with Reactive, not hee hee ha ha. This is like, give me the ID. Where did I put it? Do you want a joke here? I will define a variable. Post ID. Right. What variables? You don't have any. Good. So where do I get the post? The last time I saw the post was here. And then bye-bye, because when you did flat map, you lost it. It's now a mono of a comment. So the first thing I would want to do is to take this and bury it back in this lambda. I didn't change anything yet for this. But then this flat map, the flat map changes. The flat map changes the element from circle to square. From circle to square. I don't want to change the element, so therefore, I'm going to use here delay until. What is this? Delay until. If you remember, it plays the publisher, but returns the same circle from above. Oh, how cute. Isn't that cute, right? Nice. So then I get the ID. Do I get the ID? Let's see. This is the mono of a post, and why can't I say post get ID? Let me check the post. Do I have in there, I hope, the ID? Yes, I have. Because bad habits.
My bad habits lead to late nights ending alone. Conversations.
Anyway, so a Lombok. And back here, I want to say the get ID. Don't I see the get ID? What's wrong? I don't get it. It's a mono of a post. What stops me from doing this? If I, of course, I return a long out. Something is fishy. What am I doing wrong? Save. Let me double check. Let me, old school. Yeah, let's see. Now it works. What's wrong with you, Lombok? Aren't you feeling well today? Do you want to rebuild? Maybe. Something is strange there. Lombok should have done its part. Anyway, I don't want to consult Lombok now. Are you feeling well? So this fixed Paul's request, okay? The get ID of the post is now out. Fun. Next change request. You're gonna love the next one. Next change request is actually like you said. This takes too long to complete because this post created this sending of the post created event. This thing over here takes too long, and I want to parallelize this with this. Exactly what you said before. I want to make this work in parallel with that. Before we proceed, let me check if we are on green. Okay, simpler. Keep it simple, all right? And wait a second. Create comment fails for locked post. We have a problem. Let's see. Comment reject. Oh, the error. Hey, who cares about the error, really now? I mean, like, and an exception is okay. Don't do that. Don't edit your tests if they fail. But for the sake of the audience, I'm going to simplify a bit. No one saw that anyway, except you and others. So delay until. The problem over here is that this and that have to work at the same time. What I want to do first is highlight the fact that they are 1 and 2, both delay until. What operator will I use to call them in parallel? Zip. So in the delay until over here, I'm going to do a mono.zip, and I'm going to zip the two things together. Send post created event with all this beautiful code with this comma. Now, this zip over here is going to return me a mono of course, we did not see tuples today. So we had to see tuples. Life was so fade, and what compares to a mono tuple 2 of a void and comment? That's all you wanted to see. I don't really need that anymore, so I will just say them. Okay? I don't really care about that, and I'm going to return this out. All things good, we're good to go. Mono zip of these two in parallelization. Parallelization. All right. Let's see what happens now in my tests. Okay, let's see. Uh-oh. 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 Get new post detail. Initial comment wasn't saved. Yeah, that's one pitfall, a big pitfall, with zip turned yellow. Calling zip method with mono void parameter will not have any effect. What is he talking about? It's about what these two things return. This one is a mono void. To remind you what we are doing here, we are sending a message over a rabbit, over a reactive rabbit. So inside of there is a little rabbit returning you a mono void. A mono void because there is nothing to give back from a message sent on the on a queue. So then what happens with the zip if one of these two completes with empty? And again, look, merge given monos into a new mono that will be fulfilled on error or empty of any source will cause other sources to be cancelled. So if this baby is not there, when this completion signal hits the zip, in that moment, this guy is going to issue a cancellation cancel. That's another thing that no one talks about until bugs. Is going to hit a cancel upwards to the other one that was just trying to save in the repo, saying, I cancel, I don't need that. Right? What the heck? It's basically canceling the create of an initial comment when the void here comes back. Right? Folks, this is hardcore mode. This is bugs in real life. What people do here, they smile and they say, then return 1. What? Yes, 1. Do you want 42, the answer of the universe? Maybe that's better. That makes much more sense. 42. You look at 42 and wonder, what the heck is wrong with you? But the tests are green. Why? The tests are green. Look, the tests for this particular flow. Because now you are returning something, some rubbish. I don't care, but it's returning something. Right? Not empty. Not empty, please. I've heard other fun people saying optional empty. Pour les connaisseurs. It's something not null, but it's there, something, okay? So, not empty, please. Weird, huh? So monozip will cancel the other one if anyone fails, right? And the delay until and all the kung fu to parallelize this work, okay? In parallel, right? Right? So, nice, turbo, exactly. All right, next one. We have like 2 more tests which are failing right now. Use case 2. Oh, I want to show you one more thing before we proceed. I guess no one really noticed the transactional. What was that? Transactional? Whoa. Yeah, we have SQL, remember? SQL can do transactions. Ooh la. And they are not lost in Reactive. Now, anyone knows where the transaction is stored in an imperative Spring app or any app? Where is the transaction stored? How is the transaction propagated within your flow? In a thread local variable, using some magic state. Instead of thread local, where do you think the transaction is propagated now? With the reactive context. Anything that used to be on the thread local now moved to reactor context, as well as transactions, and these work. I have a test proving that. Trying to insert a comment that fails because the title is too long. You can look in the tests, and really, they failed. When you try to insert a post, which goes okay, and then the insert for the comment fails over here, this one is rolled back. I think I can actually show you that. Let's try. I'm not sure if I see the rollbacks. I don't see the rollbacks in the log, unfortunately. I don't think I see them. Just SQL, but I don't see rollbacks. No. Now, here. Insert into post and insert into comment, initiating transaction rollback. Because I tried to put a name here which was too long. So use case create post transaction failed. I have a test that proves just this. Okay? So transactions work. Good. As long as you propagate the reactor context everywhere. But then one guy, because it's tired and bored, blocked. If you do block, reactor context has no way to jump over the block because it's a new subscription that you're constructing in there. You are constructing a subscription and blocking your thread to get it done. That does not propagate the reactor context over. That's one very important thing to keep in mind. All right. Let's move to the use case 2. What is this trying to say? Get all authors. By the way, we had a discussion after the previous deep dive, and there was one of the participants told me what I like to hear, that the first thing they review at a pull request, they review the tests. If she could not understand what the tests were trying to prove, reject pull request. If the tests are not expressive. So use case 2, get all authors again is faster due to caching. Ooh, timeout. What do you know? So we mentioned load testing. So let me introduce it to my friend Wiremog, who, if you want to fetch the contact email, it has a delay of 100 milliseconds. So I'm trying to fetch again the email of an author. And it should finish below 1990. Do you figure out why? If it's 1990, if you would really do the call that takes 100, you would not fit the timeout. Make sense? So it will blow up. It's a check for the cache. So it's a cache. We have a cache. Ladies and gentlemen, we have a cache. They're gonna kill me when they publish this on YouTube because this. Anyway. So cacheable. Sorry, there will be a lot of awkward silence in the recording, but it's for your fun. A cacheable of contact email. This problem, a friend of mine. Wait. I'm looking in the wrong place. My bad. I'm looking in the blocking application here. It's copy pasted from there. This Friday, a friend of mine in Spain, with which I coached for a while, had this issue, and we pair debug it. Friday at 6 p.m. my time, we were debugging this. My wife was like, "What are you doing? Your workshop is done." Yes, but I have this, Eduardo, to help, please. Cacheable. You know, what does cacheable do, annotation, in Spring? It wraps a proxy. It wraps a proxy over. Now, what happens if you call the same method with the same arguments twice? The same, the proxy, let's draw this. I like drawing a lot, as you can see. The first call that goes through to the method, the first encounters the proxy, which sits in front of that method, the caching proxy. The caching proxy first time sees you don't have anything in cache, allows you to go through. You do this kung fu here, you return out. The second time you call this method, you're going to hit the proxy, and the proxy says, hey, are you coming with the same author ID? Yes, I do. Then you don't need to go inside. I can give you the value returned the first time to you also. You see my point? It gives you the same value. Fun, easy, magic. What can I say? Magic. I want to say one thing that got us into a headache a lot. We looked for this in the log. Let me clean the log for the reactive application, run the tests again, and then go here and see how many times do I see the retrieving email for author in the log of my application. Once. This method, this log, is printed a single time. With my friend, we were like, so the cache works. Yes, it works. But then why does the test fail? It didn't work. Wait. I have to tell you a bad news here. On that list, let's make the list, folks. Can I visual? Just a second, please. Let's put in the list here. Thank you. New and say, when using reactive, I wish I had more than that. Fair logs. And then I say variables. If for what else? Throw exceptions. Throw and catch. All right. I think there is one more, but let's see in my code what this leads to. This log is lying to me. That log is lying to me. What does that log tell me? Trying to tell me that I'm doing a network call. Right? Wrong. When that log is printed, nothing happens. When will the network call really happen? Tell me. When what? When you subscribe. When you call a method returning you a mono, nothing happens. Nothing. No network call, nothing happens. Unlike the case when you use a completable feature. A completable feature fires up directly. It's safer than mono, right? And I know a CTO that has banned Reactive in their code base. He said, okay, you want to use web client? Go ahead, but then you do two feature, and you're back on safety. You see my point? Completable feature, you're back on safety. That's a fair point. You want asynchronous processing or orchestrating some stuff, but you don't want to enter this lovely world we are describing here. Good. So what I'm trying to do here is this log info is misplaced here, is lying to the reader. This is not when the call is actually submitted. But where do I put that log? In a hook. Remember those signals that you see the first thing when you wake up in the morning on the ceiling? You have this printed when you lie in bed, you look at the signals, right? So what do I hook on? The subscribe. This signal. When I'm asking for data, give me, that's when the request really fires and the connection is established on the network. So do on subscribe. It gives you something you don't need, and then you put this. This is when the request fires for real. And tell me next, how would I log after the call is completed? Oh, I know. Don't tell me. Wait. Don't tell me. I'm gonna fix this. I'm gonna. Oh yeah. After. Good luck debugging this. Can you imagine the pain, the madness? What? Friday, 6 p.m. I was living La Vida Loca here with it, my friend. Good. And then do on next is what you want to hook onto. Or maybe do on completion. But the point, do on terminate. The point is to finish. Do on next with not firing in case you have an exception, an error signal. Do on terminate will fire. You can read the Java doc, but let's, for fun, do on next. And then the element, the actual email that comes in, I'm going to log info, and I'm going to say got the email. And we're going to look at the log timestamps. Have you ever looked at the log timestamps? To see how much that call took? Like old man's debugging performance. Let's see, Flux. To be safe, I should have run it again. Let's run it again. I'm going to clean the log, fire it again. Good. And now look inside the log to see how many times does this occur. Alarm. Because now I'm logging in the right place, right? Because now I'm really logging in the right place. And you can see between these two, 100 milliseconds. Beautiful. And also you can find something more dramatic. Here we are landing on a different thread when you come back. You request the data on one thread, this. You get back the data on a different thread. Isn't that lovely? Every time, yeehaw, juggling with threads, fire, get subscribed. All right. It's normal because there is no thread waiting for the call to complete. You just fire and leave. All right? And in the background, stuff keeps working. Done. So this is got response. Logs, okay? How to fix the bug, the performance issue? I have cache. What cache? What? Maybe there's some reactive cache. You've met the reactive cache today. What? Cache the mono before returning it. Exactly this. I'm going to cache a cached mono. I'm going to cache a cache mono. I'm going to say that 3 more times. I'm going to cache a cached mono. This cache is going to contain a mono that is cached itself, so whoever comes and subscribes again is not going to fire more network upwards. It's going to serve the same response cached inside. Oh my God, this is so weird, right? Method calls. Actually, I can't put it there. But anyway, very weird. So cache of cache. All good? All good. Now is the time to be honest with you folks. If your game was to write code like this, if you were in the reactive programming world just to optimize performance, just to be more scalable, to be able to take hundreds of thousands of requests in parallel, historically that was not possible until Java 21 in Java. In Java, the thread model bound a Java thread to an operating system thread that weighted 0.5 megabyte of stack. That was a terrible waste of resources to fire network and wait blocked in a thread. Virtual thread changed that. If what you had to do by everything we've seen today right? This Flux is not really supposed to stream a lot of responses from the database. I don't have that many. You will find yourself just returning list mono. In here also, how many posts do I have? This find all is able to stream gigabytes, but is that what you want? Do you want to push 1 gigabyte of posts over the network to the browser? What would Chrome say? Hey, 1 gigabyte of JSON, super. Right? Depending on who's on the other side, it could be this. So, in theory, Reactive here would allow you to send millions, billions of elements over the network, over HTTP to another system, not browsers. Probably not browsers. But it's not something we want to do, perhaps, in here. I don't think we want to do that, right? Probably you want to page something. Get all authors. How many authors do you think I have? Get post detail, that's a mono. Create post, that's a mono. Create comment, that's a mono. I'm not just returning a single thing, asynchronously, yes. We are in this game here just to optimize performance and be able to take a lot of load. No use case until here really deserves reactive programming. All right? But you can encounter any of these cases when you are really playing with, look, use case number 6. Last use case to migrate. And that gets much closer to reality. In this case, I have this post likes. We have a list of post ID to the number of likes it got. Good. When I go to get mapping post ID likes, I can see how many elements got, like the post number per post ID. Now, see here that I'm using the Spring functional message listener. I'm publishing a bin of a consumer of like event, and this function has in the property file is bound to a rabbit queue called likes. I'm not sure if you are familiar with this. It's a fancy way of listening to queues with Spring Cloud Stream. Right? On like event in 0, the first parameter of this function, the like event in here, comes from the queue called likes. So this automatically binds to rabbit and listens to messages on that queue, this chunk of code over here. Now, every time I receive a like event, I take the post, take the likes, and store them into my map. It's like a sort of a cache made back home here in the basement, right? I am remembering all the events about the likes I got, okay? So if I restart the application right now, you're going to see the listener receiving, I hope, receiving events. A lot of events in here. If I want to see the likes for any given event, I can go to post ID likes. Let's give it a try. Chrome, wake up. All right. So localhost 8080/post/1/likes. It's very, now, let's try for 2. What am I doing wrong? Did I restart this? I think I did. Get post likes, get or default, post ID, good. And my events that are coming, they come for post 2, 4, 5, so that should have worked. The only problem, I'm targeting the blocking application, not the new one. And the blocking doesn't receive messages. So 8081. As you refresh the page, you're going to see a larger and larger number of likes. We all want that. More likes. Likes, right? And you keep refreshing to see the new value. But then, you know, when you are in Twitter, oh my bad, X. When you are in X and you open it, don't say it. Okay. When you when you open a post and the heart. Or the like, or the heart, you want a user effect. You want to improve the user experience. Can you imagine how glad the users will be when they will see the likes rising like this? And then lowering. Right. So I want this behavior. How can I do that in my browser? I need to push from the server to the browser the new value every time it comes. Ooh, can I do that? Of course. Introducing event stream. Ever heard of WebSockets? Rest in peace. I can't say that. Look, the problem that WebSockets were trying to solve is a way to push for the server to push data to the browser, right? That's one key goal of WebSockets. This does the same thing. What does this do? It's a special content type that if the server returns to the browser enters a persistent state of connection with the server and keeps waiting for data frames, for traffic on the TCP/IP connection. So it effectively opens the door to push stuff from the server to the browser. Right? All the browsers know this already. Now, what I can do here to start with something simple, I can do a flux dot interval and emit every second one. Do a, I can just return it. Dot return, like this. There. The only thing is that this is a long. Okay, just to see something on the screen. When the browser will connect to this, you're going to see live data. Do you see the loading? Still loading. And the elements keep coming. This is what can enable me to send data from server to browser without any WebSockets kung fu, just with HTTP connection. Okay. Very fun. Many teams are choosing that over WebSockets. WebSockets are tricky with security, are all sort of weak. You can just maintain a connection to the server and then fire get and post request if you want to send something from the browser to the server, like in the old days. You don't need to change the paradigm to that. Server push, if you want. And these are called server sent events, SSE, if you Google them. Good. And now comes the requirement. I want to push the live likes for the post number, whatever you want, to the browser. How can I do that? Ooh la. Well, they come in asynchronously from Rabbit over here. I want to take them from there and publish them in the browser. Can I do that? Let's see. This is a real scenario. People ask me, 3 or 4 people ask me, where should I really use reactive programming? When you want to orchestrate signals that come to you asynchronously. And this is a signal, like event. The first thing to change here is to tell Spring that you want to consume these events in a reactive way. I can just tell Spring, you know what? Give me a Flux, please. What? I can give you a Flux, and then on the Flux, we're going to do something that we never did before. Subscribe. But you said we never subscribe. I know. I lied to you. I lied to you. You are now prepared to tell the truth. We do subscribe if you listen to an infinite stream. This is an infinite stream. Rabbit will never keep quiet. We're gonna keep hitting you. Or if you want a more steroid version, a Kafka. It's gonna keep hitting you, right? So, one thing, I don't like to subscribe like that. Usually the tradition is to put a do on next and then end with a subscribe. Tradition say it, I don't know. Okay. I want to comment out the log. I won't need that anymore. And that will collapse me into a single line. Perfect. And then let's see, how can we do this? How can we, in this case, return to the browser something that, how can we return to the browser something that will keep updating in the interface? The thing that we are missing right now is the concept of sync. This sync is it's a sort of an in-memory event bus, if you want, in a reactive version. A reactive version that would emit to me the integer, the number of, actually, let's emit the whole event, like event. So what's going to happen? I'm going to listen to Rabbit, and every time this Rabbit is receiving a message, I'm going to publish on this sync. This says event sync equals, and I'm going to say syncs dot. I'm going to fire multiple information through that, and I want to multicast them to all interested parties. And then,
Ooh, what does this button do?
Oh. Welcome to Reactive. What if the Rabbit is so fast that you can't push to browsers? Okay, it doesn't really make sense here. But I could imagine a slow connection. The guy is entering a tunnel, and the browser is unable to... the server can't push to the client because the connection is down, right? What will then happen? Do you want me to buffer your data until you get out of the tunnel? Or do you want me to drop them? And so on, and so on, and so on. It's about the publisher exceeding the rate in which the downstream consumer subscriber can process the data. I'm going to do direct best effort here, which means that if you are out, I'm not going to remember any messages for you. If you are more familiar with message queues, that means durable subscription. Durable subscription, if that makes any sense. Good. Event sync. What do I do next? Well, I want when the Flux hits, when a new event comes in, do on next. I want that event to do event sync dot try emit next of event. We are getting close to very dangerous situations in here. For instance, it's a very creepy, very complex problem. What happens in case there is an error, exception, here or here? We're going to go there in a second, but exceptions in infinite streams are a no-no, are very dangerous. They're going to stop the stream and disconnect you from Rabbit. We're going to get there slowly. For now, any event coming from this Flux, I'm going to try to emit using this broadcaster that is multicasting to everyone interested. Right? What will I do here? Now, I'm curious. If I will write the first line. It's the event sync, as Flux. What would I do next? I will get all the events received over Rabbit. Now I'm receiving them for my HTTP request. What next? Remember the requirement. I want to push the likes live to browser for that particular post ID. What's inside the like event? I need to filter, exactly. I need to filter to see that the post ID in the event matches the post ID on my request. Make sense? I'm interested in only my likes. So, filter. Dot filter. And given the event, please make sure that the event post ID equals post ID, because it's primitive. What I got up until here, it's still a Flux of live events, of like events. What next? I need to get the integer out of them, the number of likes out of them. That's easy, that's a map. It's a map because it's in memory transformation. I don't do network, I can do map. So given the event, arrow, event dot likes. Okay, let's use the methods respectively. Good. And of course, for that. Good. Wow, so what will that do again? Is gonna filter from those many events, those that I need, and they're gonna push me to the browser? Really? Can it do that? Let's see. Refresh. Oh my God. And the browser is keep floating, right? So that can allow you to push notifications. Let's see some examples. Your job is done. Your cake is done. Your import is done. Here's your new geolocation on the map. Here's where Glovo, a takeaway food panda, is coming to you on the bicycle. My God, on the way here, on the walkway, hundreds of bicycles. I took my own Lime to get here because I couldn't just walk. Everyone was riding a bicycle. I had to ride something. But hundreds and thousands of. I love it. So where is your courier approaching you? How do you display that in an application? Live refresh of data, right? Chat messages. Hey, I'm here. I'm your dedicated ChatGPT support guy. Tell me what's wrong, right? Those chat messages, those communication with the browser, bidirectional events coming from Rabbit, they are suitable for this kind of. You can't do this with virtual threads. All due respect, you can't, right? Good. So, all right. Well, what next? We have an event sync broadcasting to all the interested parties. The events coming from this flux of messages in Rabbit. What happens if a message here blows up? Or actually, I have another to-do before that. I'm going to show you the next to-do. And that's a very common use case. Reactive programming is used in industry to do enrichment of data. On one side, you get some response from somewhere. I don't know. for each element, you bring more data from Redis, from other things, from your Mongo Cassandra. You package a new response and you send it to others. Again, signals coming in, you orchestrating things, and then you send to others. But let's see here the request. Every second, why every second? Because the number of events I receive, it's very, very high. I receive 1 like per millisecond, you can see. I don't want to flood. It's too much pressure on me. And therefore I say, every second, emit the titles of recently liked posts. What do you mean? Signals were going to come in. Every second, get everything that came in, put in a list, and emit the list. Next second, the same. You see what I'm doing? I'm doing sampling, basically. Hey, what is that? Or packaging them together, enriching them somehow, and sending further on another rabbit queue. Right? So let's try to do that. Well, the first thing first, how can I get the title of a post? I need to fire up to outside messages of this type. Let's first construct messages of that type. Okay, I'm going to commit this first once and say live push data in browsers. We say bro, right? Always bro. Good. Now, how do I get the title of a post? Let's write here. What would I do? I have an incoming flux of messages from Rabbit on the queue called like events, likes. For every incoming message, I need to do what? Let's brainstorm. What should I do here somewhere? I need, inside the event, I only have the post ID and the number of likes. They don't know the title. I know the title. I need to flat map. But you said directly flat map, knowing that I'm going to hit network to bring the title in. I'm going to flat map, and I'm going to say, per each event, I need to hit my repository for posts. Public final, post repository. And then this post repository dot find by ID. Make sense where I'm going? I'm going to find by ID per each event dot post ID. What I get back is a flux of posts. What next? I need to push out only the titles, not the whole post. The next operator to use here is what? It's a map. It's an in-memory transformation, getting the title out of the post. Now I have a flux of titles. What next? You would know this one, the next one. Huh? But yes, say it again. Buffer, exactly this. Buffer. Now let's take a moment, let's spend a moment to look at this. I will buffer, and let's first put the actual code, and then look at the picture, the beautiful picture. I want a buffer of second 1. Buffer. Now, how do you read this madness? Once upon a time, there was a subscribe upstream, asking, give me everything. Okay. Then from upstream, started pouring elements. It's pouring elements. When the elements come in, buffer operator measures time, and in a given time window, when what elements came in, they are packaged together in a list. You see? And emitted as a single element in the flux below. Next elements that come in, they get in the second list, and so on and so on. It buffers. How much work would you have to write in imperative programming to do that? I'm going to see you using synchronous map, blocking hardcore synchronize, and then deadlock. Much easier to do it with this, of course. And that's one thing in which reactive programming really shines. Another use case in the same regard I've seen, another client, they had to use some Google API, I think the Plus Code API, if I'm not mistaken. And that Google API was rate limited, didn't allow you to fire more than 100 requests per minute or something, or per second. And what they chose to do to serve many clients, they chose to package the requests coming from their clients into a bulk of many IDs, many plus codes, sent the bulk to Google. That counted as a single call. They allow you to do 100 requests per minute. Each of the requests, maximum 100 plus codes. Done. You know, they multiplexed the client requests. They put them on hold. Hold meaning mono thingy with syncs. Fired all the buffer, all the requests through the Google, got back the response, and then linked every response with a waiting client and send their. Very fun. They cut down costs. Only reactive programming can do this if elegantly. Nice. It's a buffer. That's a Flux of lists of strings. Wow. And just to see what I'm doing next, I'm going to do one next, and I'm going to say here, given the element. Oh no, I have to create the liked posts. That's very easy. I'm going to do a map. Liked posts, new. You're right. Good. And then I'm going to say the message that I'm constructed. Let me see it. Log info. Sending, but I have to still to send the message. How would I send the message? Sending message. Let's see how we go about it. Well, let's first see what's printed in the log after I restart. I want to see every second a hey, what is this? Sending liked posts. How cool is that? Sending liked posts. Sending liked. You see, there is different content because it's a bit of randomness there to make things more fun. Okay. So once I emit like 3 titles, this I emit 4 titles. Okay. Interesting. But how do I publish the message to the next queue? Well, there are 2 solutions over here. You can do on next, and then using a blocking way, send over rabbit. But if you do that, you blocking the thread over here might impede you from drawing from the incoming queue. You are again blocking a thread from Reactor, what you should not do. The other solution is to use the radioactive rabbit to do non-blocking sending, right? And the third solution is to use Spring Cloud Stream. Now, this on-like event thingy I told you about, it's more to it. You see, in Spring, if you want to send another response out as a consequence of the incoming Flux, you can make your bean. I bet some of you until today weren't even aware you can define a bean of type consumer. And now, for extra fun, I'm going to turn it into a function, for Christ's sake. What the heck is a function that, based on this event, is going to publish another Flux, is going to return another Flux of, oh my God, liked posts. And I don't subscribe myself, I let Spring do it. So, input queue, processed as a Flux with reactive programming, kung fu, produce the new message to send out on this Flux, which maps to this queue, outbound queue, sending to others, right? This is very common for enriching Kafka topics. Like you have some events, you enrich them a bit, send them further, and so on and so on. They have their own abstraction called K-stream for that, using adding more stuff to, but still reactive thinking, reactive programming in the sense. Wow. So, okay, of course you can actually publish sometimes to 2 Fluxes, in which case you will have a function tree and so on. You have Spring Cloud Stream abstractions that allow you to play in a reactive way with messages on queues. Okay? Okay, but we have a performance issue. What? Performance. That's the only thing I had to say. I mean, with this madness, performance. What performance? I'm doing something not very efficiently. Folks, look at the output. Is this what you want to see? Again, what's the game in here? I am receiving some events from that different posts are liked. Every time I receive an event, I fire, in this case, 4 queries. Why 4? Because there are 1, 2, 3, 4 titles in the end. 1, 2, 3, 4. What is the most damaging performance anti-pattern today? It's too much to ask. We don't know each other that well to ask this question, but one key mistake is paying network in a loop. Why am I doing where post equal 1? Where post equal, where post equal? What should I use instead? Instead of the equal operator. In and angels. The in. What's the point there? With one single network round trip, I retrieve everything. I don't fire. Why am I paying network? It's like 8 milliseconds per round trip. Plus, don't you care about your Postgres? I'm like, well, relax, gather everything, send the bulk, retrieve the bulk. How can I do that? Well, in principle, conceptually, how would I do that? After buffer. You have to move the flat map here after the buffer to have the list of IDs gathered. So let's do otherwise. Let's move the buffer first. So what does it look like? It's a list of like event. I don't want the like events. I want just to map the post ID. Yes, thank you. Give me the post IDs, buffer them in a list of long, emit me a list of long every second, and then what will I do with the post IDs? Find all by ID. All right? Data in transit buffer together. Once I have a page, fire it up, get everything from the database, and of course, 4 dots. Emotion, always. Pardon, wrong effect. And then post title, wait, I have a flux of posts. I have a problem now. Maybe you don't see it yet. Let me try to fix it in the only way I can. Fire it up again and show you the log, the effect. You see, the find all by ID, this one returned me a flux. So what? If from a flux you return one more flux, the fluxes are joined together. Okay, that's probably it's too much for this time of the day. But the thing is, find all by ID fires every element it retrieves from the database one at a turn. What you get at the end is no longer a flux of buffers. It's a flux of bare metal posts. That's not what I want. Because of that, I'm going to take it back to a lambda, and I don't want to return a flux, because the moment I return a flux, the surrounding flux is going to take each of my flux in the page and put them one after the other in the resulting. That's not what I want. What should I write at where the cursor is? I need not to retrieve to send out a flux of posts, but a mono of a list. It's a mono of a list. So basically, I'm returning list by list. I'm not returning 1, 2, 3, 4, 5, 6, 7, and then it joins the results. I'm returning, here's a list, all at once. Again, the diagram. These are the posts coming from the find with the in operator, 1, 2, 3, 4 posts. These posts are all bundled together in a single list, which is emitted further as a whole, not posts independent. Okay, this particular one was a bit tricky. I know. Map, title. Like this. Get the title, and only the titles buffer together, right? And then in the end, here, do a map and do liked posts new. Or maybe if you want the lambda first, the titles. All right. Okay, efficiency. So data in transit, you buffer, retrieve buffers by buffers, map the buffers, and then return a message on the outgoing flux, which are published on this queue back in Rabbit. What we see here is titles, and you see the in operator, like we should. Okay, that was fun. So, and the last, flux in, Flux out. Hell between. Okay. I know this is criminal. I know it takes 3 to 6 months to really be comfortable with this kind of technology. They're working weekly, or at least. It's really, really tricky. The last point I want to make with you today is what happens in case of an error. What do you mean error? I mean, errors happen. Let's see what happens if an event coming in does not bring in the proper, the liked post over here. Let me see, the flagged of like event, this. Let's pretend this one brings in long, like wrapper type. And wrapper types are bad for your health because they can tolerate null. So what happens then if the sender, sending me data here, fires up one day a null? What happens if there is a null coming in the JSON on the message? So what I'm trying to say is that right now over Rabbit, there will be a like event as a JSON saying post ID null. What's going to happen next? When I try to, let's see. There is a dark secret here with the put. If I'm trying to put and the key is null, let's see, let's double check if I'm right. I believe HashMap does not tolerate null keys. If you know for sure, help me out here. Let's see this. Come on, put. Big. All right. And I want to go to the, where is the put? There, put. Okay. To my knowledge, but what the heck of a synth? What is this? Did the internet just fell down or what? Do you still have internet? Anyway, to my knowledge, this put fails if you're trying to put a null key in a hash map. But let's find out together. Every second, there should be a message sent out, right? Where is the message? In other words, where is this sending? Let me restart the application, clean up. Is any sending space, is any message sent at all anymore? No. What just happened? I killed my infinite flux. Let me show you this. We're going to restart the application, and we're going to see what happens with the first message that goes in. There is a null pointer exception over here, fail to invoke function, because somewhere there at line 38, what is line 38? Line 38. Put through exceptions. Because you can't put a null key inside a hash map. The result, here comes the horror part. The result is an error signal coming out of the doOnNext method. The moment the error signal hits the backbone infinite stream, at that moment, two things happen. The error signal starts propagating downwards, as you expect, but at the same time, there is a hidden cancellation called signal going upwards to Rabbit, saying, Rabbit, I'm done, I'm dead, I don't need your messages anymore. Closing the connection to Rabbit. So the bottom line, to make it short, you are not allowed to have any errors hitting the backbone of this. And if that happens, you need to use the magic on error continue. Continue. Which I would invite you to discover what it does under the hood. It has to do with reactor context. It's a sort of a catch-all. It's a sort of an aspect, if you want. Around every of these operators, it will wrap the stuff you're saying over here. And the parameters that you are given is the exception that occurred, and the element anywhere above that caused an error, anywhere to occur. And I can just say here log.error, pretend nothing happened. To not disconnect from Rabbit. And then I will add here to the log the exceptions and the element. All right? Don't you wait for Java 24, my friends? 25. You know, right? This is going to work 2 years from now. Interpolation, string interpolation. I can't wait. So I waited 2 decades for this. Anyway, so in the meantime, plus equals plus, okay? Or mustache and stuff. But yeah, let's see. This would actually ignore some of the messages, right? some of the messages. Let's just put here get message, and let's see what happens right now when I restart and look at the log of my application. You would see some messages bringing in errors, blowing up, pretend nothing happened. You see? But you would still see sending. So you survived the error. You captured the error, handle it somehow, and you continue to consume from the infinite stream. This only makes sense in face of infinite streams. It's like a catch wrapping everything above. It's wild. It takes some time to grasp this. But on, error, continue. 5 more minutes. And I'm afraid my likes will decrease if I push harder. So let's see the summary. It's enough. It's enough. I walked through some of the biggest dramas in reactive programming. This was not an introduction. What have we learned? Let's debate a bit. A method calling network must return a publisher. Because whenever you hit the network, for the network call to happen, you need to subscribe. So what will happen? Everywhere where the network call is happening, that method is going to bubble you up a mono or a publisher. And you're going to bubble it up until it reaches Spring. In a method, returning a publisher, right? So if you declare to return a mono or a publisher, you are not allowed to block threads in any way, not even throw. Instead of throw, remember, we are going to return an error. A mono error, for example. And if you want to block, we did not talk about this today, but the only valid way to do that is with this idiom, from callable blocking code, subscribe on bounded elastic. Right? So you can still use Hibernate. I have groups, client company, that are using still Hibernate with reactive programming. I wonder what's the purpose. The point is they are wrapping Hibernate calls in this blocking of from callable subscribed on. I don't say it's a good thing, it's doable. Or if you have some library that blocks inside, doing some sort of file access, I don't know. Right? Every publisher must be subscribed. If you don't subscribe it, nothing happens. And be careful to subscribe it once. Remember when we fired the select twice? Don't subscribe, or 3 times. It was 3 times. Avoid keeping publisher instances in variables. I told you, we chain one next to the other. The idea came from you in the break. Why can't we just do a single flat map and then in that lambda use the post, it was the case, multiple times. What's happening with animation? Anyway, mind the signals in the marble diagrams. Be careful what your operator behave when you do an empty, when they receive an empty mono from above. Mind what happens if when they cancel. No one says about, very few operators talk about cancellation. The zip one we saw today. And mind the subscribe signals, the subscribe errors that some diagrams don't display. The request metadata is now propagated using reactor context instead of thread local. We just a security context holder, sleuth trace ID, transaction. These are all moving in reactor context. So that's why you don't want to do block or subscribe, to propagate it upstream. Return your publishers to Spring. If you can, if you are in a web controller, in a REST controller, you just return to Spring and Spring handles everything. Spring passes the reactor context, manages cancellation, and subscribes to your stuff. Avoid doing subscribe and block because that would not propagate those information except for startup, blocking message queue listeners, and timers. It's a tricky thing here. If you are listening to Kafka and you don't block the Kafka listener in an imperative way, Kafka is going to ship you more messages, flooding you, basically. So you might want to block that thread of the message queue listener to tell Kafka, back up, relax, I'm not done. Don't push me more messages. We need to be also, with the group, with your team, you should be super experienced with functional programming. There should be no mystery about what functional programming is and how to use it, right? Learn the operators. The single was a very good operator, okay? Avoid excessive lambda in lambda in lambda. Take it baby steps. Try to do initially web client block, and then go more than that, only for those hot flows. If you have some flows that are really under pressure, embrace reactive chains on those flows only, right? And if you're playing with infinite flux, beware of cancellation. All right. Virtual threads, but you know what? I'm going to invite you to look at what the conclusion that Venkat had in that room. So I'm not going to compare virtual threads with Reactive today because it's already in progress right now. Instead, I'm going to list here below some use cases where reactive programming is still king. When you want to handle async streams of events, of signals, coming from sensors, from browsers, from message queues, if you want to have bidirectional server-browser communication, if you want to stream a lot of data over HTTP or some RPC to some of your clients and allow them to back pressure you, to throttle, to flow control you, and since Java 21 is no longer suitable, don't go reactive just to be able to take more load with less resources, because that's achievable for free with virtual threads. And one more warning from the Reactor team: do not mix virtual threads with reactive programming. It's tempting, but don't, because everyone will just blow up. It's very hard to grasp both concepts at once. Virtual threads have their own thing with structured concurrency, with scoped variables and stuff. Reactive programming has its own madness with cancellation signals, reactor context, and so don't try to do both. Choose one. If your use case is on this list, perhaps Reactive is the way. All right? So if you are using Reactive right now, I would invite you to take this stuff, do it with your team together, make all the tests green, and explore different ways. There are multiple other ways to write those flows than this. And with that, I thank you all for your attention, and I will still be around if you want to chat about anything. Thanks a lot for keeping up with me, for staying with me for such a hard topic, and yeah, we'll have a great conference tomorrow and the day after. Good.